But we have a bit of a catch-22 here because we don't know exactly the type of exception that we received earlier. Welcome back to episode 7 of Haskell from Scratch. I received some comments on the last episode about using a syntax checker from inside of Emacs so that I don't have to switch to the console, compile, find an error, and switch back and correct it in my editor. And this is a great suggestion, and I'll be setting it up. I've started work on it. But I want to make sure it's set up nicely, and I also want to document the process for you if you're interested. So that will be coming after we've finished this latest feature of the prototype. Now, this latest feature that we're working on is redo-ifchange. Inside of the do script, we have redo-ifchange with the dependencies listed. And in the last episode, we had gotten it to the point where we were passing the redo target and the dependencies to the redo-ifchange script. And I'm going to continue implementing it in a script just for rapid prototyping purposes for now. One of the features that's listed for redo that is supposed to be an improvement over make is that instead of using timestamps to determine whether or not a file is up to date, it uses something else. There are a few different approaches we could take to this, but I think the simplest for now is to just use a checksum of the file. There are a handful of different checksum algorithms that we could use. For example, SHA 256 seems to be in favor right now from a cryptographic standpoint. But even though MD5 is weak cryptographically, I think it will work just fine for our purposes, and it has the benefit of being more familiar and having some tools available for it already. For example, on FreeBSD there is a MD5 command. It also has an SHA 256 command. And on Linux, I believe there's one called MD5 sum. So if we type MD5 and give it a file name like redo.hs, that gives us the MD5 checksum or hash for that file. So if we then make a change to redo.hs, let's just, why don't we go ahead and remove this tracing that we put in previously, which I don't think we're going to need. We don't need to trace the process, we don't need to trace the exit code, and while we're at it, I don't think we need these derived instances, and we can go ahead and take out standalone deriving. So now, the checksum for the file should be different because we've changed it. And I'm just going to recompile just to make sure I didn't mess up anything in the process. Okay, so what we need to do at this point is whenever redo-ifchange is invoked, we'll record the MD5 checksum of each of the dependencies that it receives and store that somewhere in the file system so that on the next run of redo we can compare those checksums with the checksums of the current files. If that seems a little bit abstract, just bear with me here for a moment. So what we want to do is for each of these dependencies in the list of arguments that we receive, we're going to store them in a directory .redo so that it'll be hidden from a normal file listing or a directory listing. Then a subdirectory with the target name, so that'll be the directory that we're in. And then we need to store the MD5 checksum in the file. So we run MD5 on the dependency, and we can redirect it to this new directory, and the file name will just be the dependency name. One thing that we need to do is notice that MD5 by default prints some extra information we don't need. If we add the Q for quiet flag, we get just the MD5 checksum. So let's add that here as well. And so now let's give this a try by running redo. And if it worked correctly, we should have the MD5 checksum. Let's check what that is for redo.hs right now. in a redo.hs file, and we do. So now if we were to run redo at this point again, we could calculate the MD5 checksum, compare it against the one stored in that file, and determine if there have been any changes since the last run. So our redo-ifchange is good enough for now, and we can move back to working on how to check the MD5 checksum in the Haskell code. So what I think we're going to want is a function called, let's say, UpToDate, that it'll look a lot like the type signature for redo itself, where UpToDate is given a target name, and instead of returning nothing, we're going to return a Boolean to indicate if the file is up to date or not. So if we return false, that means, go ahead and rebuild this target. And if we return true, we don't need to do anything. So to determine if a file is up to date, we basically want to go through this directory that we have here, this .redo, and then the target name directory, and check the checksums of every file inside of there. Every file is a dependency. So the first thing we'll need to be able to do is list the contents of a directory. And I want to show you a quick way to, I'm going to exit GHCI, a quick way to browse through and find a function if you don't know exactly what it's named. We can assume, though, that system.directory has something that we want. So let's import system.directory and then just browse the module. And here's a promising function, get directory contents, and we just give it a directory path, and we get back the contents as a list. Notice that this also returns the dot and dot dot directories. So we're going to have to filter those out somehow, but this gives us a start. So let's say that we have the dependencies are get directory contents. Let's go ahead and import that before I forget. Of the dependency directory, where the dependency directory is the target plus the, it's going to be .redo plus the target. And I mentioned in the last episode that we don't want to tie ourselves too closely to Linux or Unix or a POSIX system, because since this is a build system, it would be really nice to be able to have it work on Windows. And one thing we can do right now to help with that is not assume that the file path separator is a /. There is a function in system.filepath, or an operator that looks like this, that will go ahead and join two directory components for us. So now what we want to do is check that each one of these dependencies is up to date. So we're going to need a function for that. Let's just call it dep UpToDate. And it's going to take a file path and return a Boolean. Now before we implement the body of that helper function, let's just assume that we have it. So we want to apply this function to each of the dependencies. And if we come across a dependency that is out of date, we can immediately know that the entire target is out of date. The first thing that jumps to mind for me on this is if we map this dep UpToDate function over the dependencies. Let's bring this up to the middle of the screen. We can then check to see that all of the dependencies are true or up to date. And one way to do that is with a list function called all that takes a predicate or some function to check each of the elements of the list against and returns true if all elements of the list are true for that predicate and false otherwise. And since we're going to have a list of Booleans, we can just use the identity function for the predicate And so say we have a list true, true, false, true, all would be false in that case. If the list was entirely true, then it's true. If we have just a single true, it's true. And then in the case of the empty list, it's also true, which if you think about our use case is the correct case for us as well, because if there are no dependencies, then the target's up to date, or at least it seems like the correct thing, and we'll find out in the future if that's incorrect. So let's add all ID here and lift this, and just to test that this compiles, we'll set this to undefined for now and compile. Okay, so the next thing we need to do is actually implement the body of this function. But you know what, before we do that, let's make use of up-to-date before I forget to here in this redo function. So we'll say up-to-date prime is up-to-date target, and if we're up to date, then we can just do nothing. Otherwise, we will go ahead and rebuild the target. And there's a somewhat more compact way to write this. If we use unless from control.monad, we can just say unless this is up to date, we'll do the following. So, okay, now time to implement this function. So the first thing we want to do is get the MD5 from the last run that was put there by our redo-ifchange script by reading the file itself here, and that's going to be the dependency directory and the dep name, which goes there. And before I finish writing this function, let's just return false. I'd like to actually take a look at the MD5 to see how it's coming out here. So we can put in a trace show, lift it into the monad, and let's try compiling that. Oh, looks like I built a version and left the undefined in the body. So and this error would seem to indicate that I've gotten my precedence is wrong there. Okay, so now let's see what that MD5 looks like. And we have an error, which you might have seen coming based on what we saw inside of GHC earlier with the get directory contents call. Our code is trying to read file on a directory. And when it does that, we're getting this error, open file inappropriate type. So this is an exception in Haskell, and depending on who you ask, this can be one of the worst parts of Haskell, error handling, exceptions, and so on. And some people will go out of their way to avoid exceptions, and one way for us to do that would be, for instance, to check if the file that we're trying to read here is a directory or a regular file. But there are a number of reasons that read file can fail, and even though I call this a prototype, I'm thinking of this implementation of redo as a solid production system, and so we should really be handling exceptions like this. So the most basic thing we can do is use the function catch, and catch will allow us to add our code like normal in a IO block here. And then we specify a handler for what to do when we catch an exception. So what should we do if we have an exception? Well, for now, let's just return false. And say if something went wrong, then this target's not up to date. And we'll just ignore that this may be the case where we have one of these special directories. So let's try compiling that. And again, I've gotten redo into a state where it's not going to rebuild itself. Catch is part of control.exception, at least for the new type of exceptions. And we get an interesting error here. Once you've written Haskell for long enough, you start to get used to these error messages and picking out the part that best describes what's going on. And the line that jumps out to me here is the type variable E0 is ambiguous. And what's happening is that in Haskell, at least with GHC's newest implementation of exceptions, you need to explicitly tell the compiler which type of exceptions you're going to be catching. But we have a bit of a catch-22 here because we don't know exactly the type of exception that we received earlier. If you look at the line that had the error printed out, we can guess that the exception is something about an inappropriate type, but we're not really certain. So we need some way to find out what this exception is to begin with. And one way to do that is to just catch all types of exceptions, which you'll see all types of warnings about doing, but we're just going to do it to find out what the type of this exception is. And to do that, we need to bring in some exception, which is, you can think of it as being the root exception type. So let's say some exception E, and this is a constructor match here. So that's going to tell the compiler that we want this type of exception, or really any exception. And then we can just go ahead and print it out. So show E, but we need a way to print this out to standard error. We already have that imported, so H put string line standard error. So now let's try this again. And now when we run redo, we get this error again. Now we get it twice, and redo proceeds. And that's because we've caught the exception and we didn't rethrow it. You might be able to see this happening a little bit better here if I put in a trace show here. Let's do it like this. Whoops. We'll want a trace show of this. So now when we run it, you can see this false being printed out is saying that the target is not up to date. And so we're making some progress, but this still didn't show us the type of the exception. So one way to find that out is that the newer exceptions are all typable. They all have data.typable instances. So we should be able to use type of to find the type of this. So let's rebuild and then run it again. And we get IOException. Okay, so that's narrowing things down a little bit, but IOException includes other types of possible IO errors that we want to be able to treat differently. So let's take a look in Haskell to see if we can find anything about IOException. And it mentions that we should take a look at system.io.error. Now, I'm going to save you the pain of actually looking through that file. You can look through it on your own. But what we want to look at is, I believe it's IO error get error type. So we'll need to import system.io error. I believe that's what it said, yeah. IO error get error type. And we can only use this function on an IO exception. So using some exception data constructor here isn't going to work anymore. We can change it to this. And the reason that this will work is that thanks to type inference, the compiler is going to know that we only want exceptions of type IOException. And this is really what we want, because we don't want to be catching exceptions like when Control-C is pressed and execution is interrupted and things like that. So let's see what we get when we compile this and run it again to see the actual error type. So the result we get is inappropriate type. If you look for inappropriate type in the IO error module and the documentation, you'll find that there isn't any function to match against this type because it's not, or presumably it's not part of standard Haskell. It is, however, part of GHC IO.exception, and if we bring in IO error type and its constructors, there's an IO error type called inappropriate type. So let's use that to check if the get error type of E is equal to inappropriate type, then we don't actually want to treat this item in this directory as a dependency. So we'll just say that, you know, this dependency is up to date, even though it's not a dependency. We'll need to return that. And we'll say that if it's any type of other IO exception, then we really don't know what to do with this, but we can be on the safe side and just say, look, we don't know, this dependency is not up to date, and return false. And we can factor this return out and get rid of this do here. And in any case we have if, then true, else false is really just the result of this comparison anyway. So now at this point, what we should get is no more exceptions. We'll still get false and the target will still get rebuilt. And it seems like we're ready to move on to checking the MD5 checksums again. But if you've been paying attention, there's still another case we're not handling here right now. Let's say that this is the first run and there's no redo directory. What's going to happen? Well, we've got get directory contents and the directory does not exist. So what we can do is add another catch here. Keep the body of our function as it is for the first argument to catch, and then we want to catch an IO exception, and if we do encounter an IO exception, then the target's not up to date. So we need to tell this that this is an IO exception that we're interested in catching. But this is not, oh my, this is the third time I've done this in one episode. This is not valid standard Haskell, and there's ways you could get around this, but I think this makes the most sense. So let's see if we can enable scoped type variables. And try recompiling. We don't need this sum exception. We can use IOException. And so now, let's make sure there's nothing, there is no .redo directory. And let's try running redo. And it goes ahead and rebuilds redo. The reason we don't see a false is that we're not getting to this trace show here. Instead, an exception is being thrown on this line, and we're taken into this IO block here, which just returns false without showing it. Now, I had hoped in this episode to get to the point where we were actually checking the MD5 checksums, but I already know that that would make the episode too long. Before I wrap up the episode, though, I want to point out something interesting that we'll take a look at in the next episode. Do you notice that the trace show here is not showing anything when we run redo? We should be seeing an MD5 checksum. So that's something to think about until next time, and we'll take a look at that before implementing anything else to see what's going on. Thanks for watching, and I'll see you next time.